So whenever I have these regular class sessions, Monday and Wednesday, I make recordings, but I make recordings at other times too, because the recordings I make when there's people present, maybe chatting or talking to me, they're just a little different. So remember there's, oops, wrong week. There are weekly videos here that I put in, and these tend to be shorter, a little more focused on a particular example. Whereas in the class, I got a whole bunch of examples I'm going over. So we just went over residuals. So this is one place to get videos where I just pick up some specific ones. But there are a ton of other videos available, and either from the syllabus or the beginning section of stuff. There's, anytime I have a class recording like the one I just made and the one I'm making right now, they end up in the 2021 playlist. And previous class recordings that are sometimes end up in those other pages are located here. And these are in order in the way, and where I get them recorded by day, and each one per day. And these are mostly in order in the way the things are covered in the course. So those are some other places. And then additionally, when you do homework problems, sometimes there's videos attached to those, and they'll either be at the top or the bottom of the video of the homework problem. So lots of video help available. I finally finished writing the quiz, so I put that in here. And those are just related to the important points in each section. So make sure you've read the book and have watched videos or attended class before you take the quiz. And then it's not a bad idea to have the book handy when you're taking the quiz, because you might need to look something up. And that can help you answer those quiz questions better. And then the application for this week, I'll explain that real quick here, is for you to pick a data set and then look for a linear trend. And if there is one, then draw the graphs and tell me about, hey, what's the slope mean? What's the correlation coefficient tell us? The thing is, you have to pick the data. So I narrowed it down just a little bit for you. There's a ton of data sets that came with the textbook. And here I just gave a link to my Google Drive version. And I picked the CSV file versions because they're just lighter in terms of their file size, but it's the same thing as the Excel files. So all of these are not fair game. There's too much for any individual to consider there. So I said, okay, pick from all of those, either use all countries, Happy Planet Index, NBA Players 2019, the student survey there, or the US states. Once you pick one of those sets, then you have to pick two quantitative variables in there to see if there's a linear trend. Are you guaranteed to see a linear trend for any pair of quantitative variables you pick? The answer is no, you're not. So it could be you pick two variables, like remember in class last time, in our average student survey, we looked at, what was it, sleep versus work, I think, and there really wasn't a correlation going on there. We couldn't find it. So then that wouldn't be a good one to do. So it could be you try a couple of times looking for a data set. And what that means is, I'll just give an example here. Like suppose this was one of the data sets. I'm wondering if there's a relationship between the population of an Oregon county and the number of COVID cases. Because I was kind of thinking, well, the more people, shouldn't there be more COVID? Right? So I would have to graph this to see. So I would say, all right, let's grab population. And then remember, to get a column that's not connected, you have to hit Control on the keyboard, hold Control, and then make the second selection. And they have to be exactly the same size. So they have to start and end in the same spot, like these two. And then I graph them and I say, okay, does it look like there's a linear trend? Oh, yeah, that's kind of linear. It's going uphill there. This might be an outlier. And so I could decide, what does it look like without that? Is that an outlier too? So sometimes when I'm playing with data sets, I might say, that's weird. I think I'm going to take that one out. So if I point to it, usually it tells me, let's try again. Who are you? It's not doing it. Why not? Click off of it and back on it. There we go. So this one, 33,000 cases. It's the highest in each of them. So I should be able to find that in the data set and then decide if I want to delete it or not. And sometimes I do delete those things. So I could just look in the list for that one. It's probably Multnomah County. Yeah, there it is right there. So I could just say, you know, I think I want to delete these two values. So I could just highlight them both and hit delete and see what the graph looks like without them. And say, okay, yeah, I think that was good to delete that. But then I'm like, oh, what about this one? So you got to be careful about trying to pull outliers out, and you want to document it when you do so. So actually, I think I'm going to put Multnomah back in. So I can just undo and it's back in. So you have to decide if there are outliers, but the rest of it looks linear, do you leave it or do you take it out? And when you do take an outlier out, it is going to change R, it is going to change M, it is going to change B. But that's just a decision what one might make. But you could pick two variables and there isn't a relationship between them. It's just this scattered bit of stuff. So let's see, if I were to graph, do I have enough information to do that? No, but I know what I can do. Just pick an example. Where's our average students? So it could be you pick two and there's nothing there. So this was full of relationships that don't exist. So for example, maybe I wonder, hey, is there a relationship between height and weekly income? I wonder. And then we go to graph it. Scatter plot. Oh, that's a jumbled mess. Okay, maybe these are outliers. I delete those and look at the rest. It's probably still a jumbled mess. So that data set, not worth looking, move on. Delete it, try again. Pick a different pair of variables. So you got to do some experimentation. It could be your first shot, doesn't work. So you just have to play around there. So again, your goal is to pick one of these. Maybe you explore a few different ones, find the data set. Maybe you're curious about Happy Planet. I don't think I wrote that one up in class yet. A, B, C, D, E, F, G, H. Double click it. And then you would have to open it in Google Sheets to do something with it. Remember, when you look at these data sets, these are just short titles at the top. You'd have to look up in the book what they mean. So this is super important too. What does happiness mean? What does life expectancy mean? What does footprint mean? So you look them up and you say, huh, I wonder if there's a relationship between footprint and HPI rank. And so you graph those two after you find out what footprint means and HPI rank means, see if there's a linear relationship in the graph. If there is, go for it. If there isn't, pick a different pair of variables. So again, you got to experiment. One thing that's important is I've done a couple of examples from all countries, US states, and the student survey. So you can't pick a pair of variables that I've already demonstrated. It's got to be a different pair. And it can't be a book that's one that's an example in the book. And so they have a couple. But there are so many variables in each of these, there's tons to choose from. So that's not a big problem. And if you're in doubt, did you cover this in class, Parker, or was this in the book? It should be pretty easy to tell if it was in the book. If it was in class, then it's in one of the videos I recorded. If you're not sure, ask me, and I'll tell you. Yeah, no, I did that in class, or no, I didn't do that in class. Once you find a pair of variables in one of these data sets that seems to have a linear relationship, then you're just going to do what we were doing earlier. Find the correlation coefficient, find the slope, find the y-intercept, and then make sure you address all these numbered points right here, and then submit a file. You're going to have to write up some explanations of things like what does the slope mean? What does the correlation coefficient tell us? And you want to do that in language that your mother or me would understand. And so that's a little bit, it's going to require a little bit of thought, maybe a couple of drafts of your sentences. Not a lot of writing here, just a few sentences that you need to write up. Three main things I asked for you to explain to me. What's the correlation tell us? What's the slope tell us? What's the y-intercept tell us? And then make a prediction. What's the prediction tell us? Is it reasonable or not? Okay, next, let's do one more example before we do some other kinds of visual displays of data. Let's go to my COVID one here. So I decided to look at the population of each Oregon county, and so I got that, I think, from Wikipedia. And then, and those are, I think, 2019 estimates of the population. And then these were the cases, total number of cases of COVID, I think Monday in Oregon. And I just made a graph of those over here. My graph needs better titles, so Zoom screen's in the way. So I should come up with some slightly better titles, like here. I would do Oregon COVID cases. I don't need that one there. That one was a footnote talking about what cases meant. I copied that down below from the website versus population. And then I think I'll add a subtitle under here that says by county. All right, so tell me what your chart means, and then make sure you have reasonable descriptions. I think population, pretty straightforward there. Vertical, I should improve that. Call it total. Oops, oh, sorry. Total COVID cases for that column. So imagine that you were getting like this published in a newspaper. What would be some reasonable titles for that? Decide if you have to remove any outliers. Multnomah County is kind of an outlier, but I'm going to leave it in there. I don't think it's too bad. And I see a trend here. So the next thing would be to calculate the correlation, the slope, and the y-intercept. So a couple ways I can do that. I can have them display in the chart just by editing it, customize the series, and say, give me a trend line and show me the equation. I'm not going to show r squared because that isn't relevant to this course. So just the equation there, or that's part of the equation, right? It doesn't have y equals, but to start. And then you have to have a good sentence explaining what each variable means. So, excuse me, sneeze coming. You know there's a pressure point between the bottom of your nose and the top of your lip right in the middle. It often prevents sneezing. Okay, I think I'm all right. So again, you're gonna have to write up a description of each of these. Now, population is pretty straightforward, right? It's the population of a county in Oregon, and these are the total COVID cases, and then I want to say as of what date. I guess I can put that here. 2021. Let's see what month is again. It's the 4th month, and a couple of days ago was New Year's 11th. So what I don't have is R, and I might as well get M and B with more decimal places here. How many decimal places do I need? Well, population is whole numbers, and the COVID cases are whole numbers, so then I should calculate the slope and the y-intercept to 1 decimal place. R we usually do to about 3 decimal places. So correlation, remember it's always y values first, comma, x values second. And make sure they line up, otherwise with the errors. That's pretty high correlation, almost 1. And I really only need 3 decimal places. Get your slope. Y, comma, x. And again, if you have multiple variables in the sheet, like the other day in class, I often will copy just those 2 to another sheet so I don't have this other stuff in the way. That's up to you. Oops, I got a mistake. Mismatch, okay, I didn't highlight them right. Oh, I accidentally highlighted the top there. All right, so my slope is 0.04, and I'm just going to get that. Now to 1 decimal place, that's going to be 0, so I'm going to have to go to 2 decimal places to explain that. And then B. So I'm just going to interpret the slope here. So I think I've done enough of these. All right, there's my y-intercept. So I want to come up with what this slope means. Let's get this in a new screen. To current. Yeah, good. So before I can write my sentence, I just got to remind myself what this, the setup on the slope. So I got my m, right, my rise over my run. I'm going to go with 2 decimal places. So as a fraction, it would be 0.04 over 1. All right, what's rising here? That would be COVID cases. All right, can't have 0.04 COVID cases, so I got to figure out how to deal with that. So that's going to be a struggle, and this is population. So at first glance, it looks like for each additional person in the population, there's going to be 0.04 more COVID cases. All right, that's not working so well. So what does 0.04 mean? Okay, let's see. This is tenths, hundredths, so that's really 4 hundredths. So that's another way I could write my slope, 4 out of 100. All right, so 4 COVID cases. So this one's a little trickier than the last ones I did. So I have to rewrite the slope population. All right, that makes a little more sense. For each additional 100 people in a county, there should be 4 more COVID cases as of this week. Yeah, that seems reasonable. I can explain that to my mom. So interpretation of slope. Is always you describe the change in the explanatory variable, how that relates to the change in the response variable. Okay, so explanatory is population, my x value, and that's a positive number. So for each additional 100 people in Oregon County, so I have to have a definition of what the variables mean in order to interpret. In Oregon County, there should be 4 more cases of COVID. And more is my indication that that is a positive number up there. These are total cases by date, so I gotta include some idea about that. That's part of this variable. As of the 2nd week of April. On average. Okay, so there's my interpretation of the slope. So that's part of what you need to do for this activity. As far as predictions go, prediction means to use the equation. So for example, if a county had 250,000 people and I plug that into this equation, what would I get? Let's do that too for fun. So again, I have my linear model. All right, this is my X, the population. Total COVID cases in April is my Y. And I think Y is equal to 0.04. So I was going to go with X plus 29.3 is fine. And I'm going to do a prediction. For X equals 25,000. So that point right there. And so if I plug that in, I got to figure out what Y is. So then I have to whip out a calculator. Oops. So plug in your X value, get a number. You can do that right in my spreadsheet. And you can either submit a spreadsheet or a Google Doc. It's up to you. So let's go down here. Say X 250.123. Y is going to be equal to 0.04 times that X value plus 29.3. All right, so I get about 10,029. Okay, so what does this mean? We got to put it in a sentence. For a region in Oregon, population 250,000, excuse me, people, we expect about 10,025 COVID cases total. In early May, April, sorry. 2021. All right, what is this? What am I predicting? All right, so that's what I'm predicting. Given this population, what's the COVID case expected? So if we looked at not a specific county, but maybe a couple of counties, like often Umatilla and Morrow counties are lumped together because they have a lot in common, that would be a slightly different region. If we look at that population, what do we expect for the COVID cases in the combined region? Or maybe we're just looking at a part, like just Portland instead of all of Multnomah County. So we could look at the Portland population versus COVID cases. Next thing to think about here, am I interpolating or extrapolating? Anybody remember? Is this an interpolation or an extrapolation for prediction?
Interpolation, because it's within the data set?
Yeah, interpolation because it's within the data set. And if you have a high R value, and we did, our R was about 0.96, it's safe to interpolate, which means make a prediction within. So this is an interpolation, a prediction within the data. So if I went for, say, a population region where there were 1 million people, that's outside my data range, that would be an extrapolation. And extrapolation is more dangerous the farther you get away from the data. And so we have to be careful of that. Given that there's only a couple of regions that have over 500,000 people, I would say predicting for a population of 1 million here is not a reasonable extrapolation, even though we have a high correlation coefficient. So this is an interpolation. Here's my explanation of it. I think this is a reasonable prediction based on the R value and that I'm interpolating. So tell me about that. Do you think this is reasonable? Why or why not? Room, and this is an interpolation. So this is kind of messy. I need to type this up so it's neater and other people can read it better. But this is what I'm expecting. I want you to make some calculations. I want you to think about it, tell me what it means. And there's just a few things you have to tell me about what they mean. What's the slope mean? What's R tell us? What's the y-intercept mean? If anything, it might be meaningless. And can we make a prediction? Is a prediction reasonable? Why? All right. So moving on,